Here is an example based on the open circuit test and short circuit test. So a open circuit and short circuit tests are performed on a 4 kVA 200 by 400 volt 50 Hz single phase transformer. Okay, we're going to do this similar test in our lab. I believe we have the similar transformer, but mostly 60 Hz transformer instead of 200 volts. I think we have 120 volt transformer. I do not remember the ratings, but you're going to do it in a week. Okay, now the OC test results are 200 volts, 1 ampere and 100 watt. SC test results are 15 volt, 10 ampere, 85 watt. So SC test is on HV side, OC test is on the LV side. Now from the OC test, what we can find RC and XM, or R0 and X0. So from OC test we have V1 equal to 200 volt and I0 equal to 1 ampere and P0 equal to 100 watt. From there we can find P0 equal to V1 I0 cos theta naught. So from here we can find cos theta naught equal to P0 over V1 times I0. By the way, when you're doing this experiment in the lab, you can measure it, okay, from the phasor analyzer. So from there I found cos theta naught, which is 0.5, and theta naught equal to 60 degrees. So now I can find IW, which is current passing through that resistance. So if you look at here, this is R0 and X0, or RC and XM. So this is I0, but the current flowing here is IW and the current flowing here is I mu. Basically, if I draw the vector diagram, here is my I0 is going to be with certain angle, which is 60 degrees in this case. The x-axis current is IW, and the y-axis current is I mu. So that's how I end up finding IW equal to I0 cos theta naught, I mu equal to I0 sin theta naught. So IW equal to 0.5 amperes, I mu equal to 0.866 amperes. Now I can find R0 from here, since I know the voltage here is V1. R0 or C equal to V1 over IW. V1 is 200 over 0.5, which is 400 ohms, and X0 or XM equal to V1 over I mu, which is 200 over 0.866, 231 ohm. So from the OC test I found R0 and X0. Now the SC test, remember SC test is happened on the HV side. Now my HV is on the secondary side, so I'm going to find Z02 total impedance equal to V2 over I2, whatever those currents and voltages. I have 15 volt and 10 ampere. So 15 divided by 10, which is 1.5 ohm. That's the total impedance. As I mentioned, you can find cos theta. You can measure cos theta also, but I can find the cos theta from here. P equal to 85 watts. So P equal to 85 watt, which is VI cos theta. So from there I can find cos theta. Cos theta equal to 85 over VI. 85 over V is 15 volt, I is 10 ampere. So 85 by 150, which is 0.566. Now cos theta equal to, you can say R over Z. So I know Z value, so I can find R equal to 0.566 times 1.5 equal to 0.85 ohms. Now X, this is basically R02, okay, because everything is on the secondary side. Now x02 equal to square root of z02 whole square minus r02 whole square. That value is x02 equal to 1.235 ohm. So the equivalent circuit I'm going to have, so here is my equivalent circuit. The transformer is 200 by 400 volt, so it's a n1 is to n2 equal to 1 is to 2. Now this value is 0.85 ohm, this value is 1.235 ohm, J of course, and here from no load test 400 and J 231. So this is 400 ohms, this is J 231 ohm. This is the equivalent circuit of the transformer. We found this equivalent circuit from the OC test and SC test. Now the second part of the question, he's asking about efficiency at half load. Okay, so off load and point, he also gave us the power factor, which is 0.8 power factor. Half load is nothing but, according to this, is a 4 kVA transformer. So half load is 2 kVA, 2 kVA times 0.8. So the load here is 2 kVA at 0.8 pf. Okay, now it doesn't matter whether it is half load, full load or no load, the iron losses are going to be same. Okay, so iron losses, what are the iron losses? Iron loss equal to, we have we just calculated or we just measured, that value is 100 watt. So iron losses are not going to change, it's 100 watt. What is the output power? P out equal to 2 kVA 2000 times 0.8, which is 1600 watt. Okay, now all I need to do is find the copper losses. Okay, so the copper losses, the given copper losses, which are 85 watt, or measured copper losses which are 85 watt, those are at full load. When it comes to the current, basically these losses are nothing but I square times R, right? When it comes to the current at half load, the current passing through this must be half of the full current, half of full load current. Okay, so all I need to do is say the full load current is X or I square times R equal to 85 watt. Okay, now at half load, copper losses are I by 2 whole square times R, so which is 1 by 4 I square times R, which is 85 by 4 watt. Those are the copper losses, which is 21.25 watt. Okay, so efficiency is P out over P in, which is P out plus P out over P out plus P losses. Okay, output power I have 1600 watt, and input power must be 1600 plus 85 plus 21.25. Sorry, this is not 85, this must be 100. Iron losses are 100, right? So 100. So efficiency equal, so efficiency usually we'll say in percentage times 100 equal to end up with 92.95%. That is the efficiency of the transformer at half load. This is, now we found out the equivalent circuit of a transformer by using OC test and SC test. Thank you.